Imagine, just for a second, a world where your daily reality is completely upside down from what you experience right now.
Okay. Upside down how?
Well, I'm talking about a world where you could taste your breakfast just by standing on it with your bare feet.
That sounds a little messy.
Right. Or a reality where you could literally feel a conversation happening miles away just through the vibrations in the ground.
Wow.
Or better yet, a world where you could go to sleep but keep exactly half of your brain perfectly awake and alert to watch out for danger.
It sounds like pure science fiction.
It totally sounds like sci-fi, right? But the crazy thing is, it's not. It is happening right now all around us. So welcome to today's deep dive.
Glad to be here.
We've got a really fascinating stack of notes in front of us today. It's centered around a collection called 100 Relaxing Bedtime Animal Facts.
Which is a great title.
It is. And usually, you'd put something like this on to just passively drift off to sleep.
Just some light background noise?
Exactly. But as we were looking through this list, we realized something entirely different is hiding in here.
Oh, absolutely.
So we aren't going to use these details to fall asleep. We are going to extract the most mind-blowing biological insights from this collection. And we're going to completely change how you view the natural world.
Because it really is a masterclass in biological engineering.
Yeah.
Just masked as bedtime stories.
Yes.
When you first glance at this material, the tone is incredibly soothing. It feels like a lullaby of nature trivia.
Right.
But if you actually stop and look closely at the mechanics of what these animals are doing, these charming little observations reveal some of the most complex secrets about evolution and survival and how perception actually works.
So whether you're prepping for a trivia night or just insanely curious about the world you live in, we're going to give you a whole new appreciation for the creatures in your own backyard.
And the ones deep in the ocean.
Okay, let's unpack this. Starting with something we all do but rarely think about, sleep.
We all need it.
We do. And I was looking through these notes on the bizarre ways animals catch some shut-eye, and the sperm whale just, it stopped me in my tracks.
It is a totally surreal image, isn't it?
Completely surreal. The sperm whale has the largest brain of any animal that has ever lived on Earth. It weighs around 17 pounds.
Massive.
And when they sleep, they don't just lay down or float lazily at the surface. They sleep completely vertically.
Right.
They hover upright in the water in these massive pods, perfectly still, like giant, silent monoliths drifting in the pitch-black ocean.
What's fascinating here is the sheer vulnerability of that state.
Yeah.
We tend to view sleep as this peaceful, restorative given, but in the wild, sleep is the ultimate liability.
Because you're just out there.
You are unconscious, unaware, and unable to react. So evolution had to engineer these absolutely ingenious, sometimes extreme ways to protect animals while they were effectively offline.
Extreme is the exact right word. Look at the hummingbird.
Oh, the hummingbirds are incredible.
A hummingbird's heart normally beats more than 1,200 times per minute.
Which is just a frantic pace.
Yeah, they are constantly on the edge of starvation because they burn so much energy just staying in the air. So at night, they enter this state called torpor. Their heart rate plummets all the way down to just 50 beats per minute.
And torpor isn't just a deep sleep. It's essentially a miniature daily hibernation.
Like a reboot.
Sort of. If a hummingbird just went to sleep normally, its own baseline metabolism would burn through its energy reserves before morning.
Wow.
It would literally starve to death in its sleep. By dropping their core temperature and practically stopping their heart, they are hitting the pause button on their own biology.
That's wild.
It's a nightly gamble just to survive until sunrise.
And if we're talking about survival sleep, my absolute favorite on this list is the parrotfish.
The sleeping bag?
The sleeping bag. At night, before it settles into the coral, the parrotfish secretes a thick cocoon of mucus from its mouth.
Gross, but effective.
Right. And it wraps this bubble entirely around its own body. It takes them about an hour to build this thing. It's a literal, invisible, biological sleeping bag.
It's a brilliant chemical defense mechanism. You see, a coral reef at night is a highly active hunting ground for predators.
Like moray eels.
Exactly. And moray eels hunt primarily by smell. So the mucus cocoon actually masks the parrotfish's scent. It acts as an olfactory cloak.
So the eel just swims right past it?
Yes. Plus, it provides an early warning system. If a parasitic isopod tries to latch onto the fish, it hits the mucous membrane first. That wakes the parrotfish up so it can escape.
It's so smart.
It really shows us that sleep isn't a passive activity in the animal kingdom. It's a high-stakes, tactical operation.
It's amazing that a fish has to basically build a panic room every single night.
A mucus panic room.
Exactly. But it's not just individual survival strategies either. I was so moved reading about how animals actively protect each other when they sleep.
The community aspect is huge.
It really is. Community sleep seems to be a massive evolutionary advantage. Sea otters, for instance, they sleep floating on their backs in the ocean. But to make sure they don't drift apart in the ocean currents during the night, they reach out and hold each other's paws.
I love that visual.
Sometimes dozens of otters float together like this in a massive raft under the stars.
It's a beautiful image. And practically, it keeps the family unit anchored together in an unpredictable environment.
Right?
You see community reliance on land, too.
Oh, like horses.
Yes.
Horses actually have a special locking mechanism in the joints of their legs. It's called the stay apparatus, so they can physically doze off while standing up without their legs buckling.
Which is great for a quick nap.
But they can't get rapid eye movement or REM sleep standing up. To get that real deep dreaming sleep, they have to physically lie down.
And a horse on the ground is prime prey.
Exactly. So when one horse lies down to get that deep sleep, another horse in the herd will literally stand guard and keep watch over them. They take shifts.
They're essentially outsourcing their security to the community.
Yeah.
And if you don't have a herd to watch your back, you have to split the difference internally. Take the ducks you mentioned earlier.
Oh, the ducks are wild. They will sleep in a row on a log, and the ducks on the absolute ends of the line will keep their outer eye open.
Just staring out into the dark.
Right. The ones in the middle get to close both eyes and sleep deeply, but the guards on the end are literally sleeping with half their brain.
The biological term for that is unihemispheric slow-wave sleep. It is one of the most remarkable adaptations in nature.
How does that even work?
Well, one half of the duck's brain enters deep, restorative delta wave sleep. Meanwhile, the other hemisphere stays in low-level alert beta waves, processing visual information from that one open eye.
So they are literally awake and asleep at the exact same time.
Precisely. And after a while, they will turn around, open the other eye, and let the other half of their brain sleep.
I can barely function if my alarm goes off 10 minutes early, and these ducks are managing two different states of consciousness.
It really puts our sleep to shame.
It does. And it's easy to look at half-awake ducks or vertical whales and think of human sleep as boring in comparison. We just get into bed and close our eyes.
But we have our own intense biology happening.
I was reading the notes on human sleep, and what happens to you when you close your eyes is phenomenal.
It really is. We are undergoing our own extreme maintenance.
Right. While you sleep, your brain is actually washing itself.
Literally wash it.
Cerebrospinal fluid flows through your brain in literal waves. It clears away the waste products of the day. How does that even physically work inside the skull?
It's called the glymphatic system, and the mechanics are incredible. When you enter deep sleep, the glial cells in your brain, which are the supportive cells around your neurons, actually shrink by up to 60%.
They physically contract.
They physically contract. This sudden shrinkage dramatically widens the interstitial spaces. Those are the microscopic pathways between the cells. Once those pathways are open, cerebrospinal fluid rushes in and acts like a dishwasher. It flushes out neurotoxins and misfolded proteins like amyloid beta that build up while you are awake.
So our brains are literally physically changing shape to wring themselves out like a sponge every night.
If we connect this to the bigger picture, it proves that whether you are a duck keeping one eye open, a hummingbird freezing its metabolism, or a human shrinking their brain cells to wash out toxins, sleep is never just shutting down.
It's real work.
It is an active, highly engineered, incredibly complex survival state that unites all species.
It completely changes how I view taking a nap. But if sleep is that intense, waking up is even crazier. We need to talk about extreme anatomy and super senses.
This is where the notes get really fun.
Because the deeper you go into this material, the more it shatters the idea that humans have the best seat in the house when it comes to perceiving reality. I mentioned tasting with feet in the intro.
Yes, the butterflies.
Butterflies actually do that. When a butterfly lands on a flower, it knows immediately if the nectar is sweet just by standing on it. But let's look at the heavyweights. Elephants.
The scale of their perception is huge.
We think of them as these massive visual trumpeting creatures, but they can smell water from 12 miles away. 12 miles, and they can hear through their feet.
Seismic communication.
Yeah.
It's a completely hidden channel of animal interaction.
They pick up these incredibly low vibrations, infrasound, from other elephants miles away, traveling right through the earth. How are they feeling a conversation through the dirt?
They have specialized nerve endings in their toes and the padding of their feet called Pacinian corpuscles.
Sinian corpuscle.
Right. These receptors are exquisitely sensitive to deep, rumbling vibrations. When another elephant stomps or makes a low-frequency rumble miles away, that acoustic wave travels faster and further through the solid ground than it ever could through the air.
Because the ground is denser.
Exactly. The receiving elephant feels that vibration travel up their legs and into their inner ear structure. They are literally interpreting geological tremors as language.
It's mind-blowing. We are walking through the savannah thinking it's quiet. And beneath our boots, there's a booming group chat happening.
That is such a vital point to dwell on. We walk through life assuming that human perception is the absolute default reality. We think the colors we see and the pitches we hear are all there is.
But we're missing so much.
Compared to the rich, invisible realities these animals experience, we're essentially walking through a symphony wearing earplugs and a blindfold.
Which brings me to the mantis shrimp. I could not believe this one.
The eyes on these creatures are unbelievable.
We humans have 3 types of color receptors in our eyes: red, green, and blue. That gives us our entire spectrum, the whole rainbow. The mantis shrimp has 16 types of color receptors. 16.
To put that into perspective, they're processing visual information in a way our brains cannot even simulate.
Not even close.
They can see ultraviolet light, they can see infrared light, they even have trinocular vision in each eye.
Trinocular.
Yes, meaning a single eye has depth perception all on its own. They are looking at a coral reef, painted in shades and dimensions that do not even have names. They're completely invisible to us.
It really makes you wonder what your living room actually looks like to a pet. But here's where it gets really interesting. It's not just passive sensing we're talking about. It's active, extreme engineering, biological superweapons.
Oh, the pistol shrimp?
Yes. Sticking with our friend the shrimp, there is another species called the pistol shrimp. This tiny creature can snap its claws so fast that it creates a bubble in the water that for a fraction of a second reaches temperatures hotter than the surface of the sun.
It sounds impossible.
Nearly 5,000 degrees underwater. From a shrimp. Wait, how does water get that hot from a physical snap?
It's a phenomenon called cavitation.
Cavitation.
The pistol shrimp's claw is engineered with a special joint. When it snaps shut, it shoots out a jet of water moving at over 60 miles per hour.
That is fast for a tiny claw.
Very fast. That water is moving so fast that the pressure behind it suddenly drops below the vapor pressure of water, which instantly boils the water and creates a vacuum bubble.
Okay, a vacuum bubble.
Then, when the surrounding water pressure crashes back in and collapses that vacuum bubble, the implosion is so violent that it creates a massive shock wave. It also creates a flash of light called sonoluminescence. And yes, temperatures approaching those of the sun.
All just to catch lunch.
They use that shock wave to stun their prey, exactly.
They are weaponizing the laws of physics. And if you want to talk about handling extreme physical forces, look at the woodpecker.
That's another great example of biomechanics.
A woodpecker is slamming its face into a solid tree trunk repeatedly. It's experiencing forces that would instantly concuss a human. Why doesn't its brain turn to mush?
The tongue.
Because its tongue is so incredibly long that it wraps all the way around its skull. It coils behind the skull and over the top of the head to act as a built-in shock-absorbing helmet. A tongue helmet.
It's actually more like a biological seatbelt than a helmet. The tongue is supported by a structure called the hyoid apparatus.
Hyoid apparatus.
In most animals, the hyoid bone is just in the neck. In the woodpecker, it extends completely around the brain case. When the bird strikes the tree, it's experiencing up to 1,200 G-forces.
1,200.
To survive that, the hyoid apparatus dynamically distributes that kinetic energy evenly around the skull. It bypasses the brain entirely.
That is insane.
It forces you to realize that nature isn't just surviving, it's innovating at a level of mechanical engineering that we are still trying to replicate.
So what does this all mean for how we actually relate to these animals? For the longest time, I think science and culture treated animals like biological robots.
Just driven by instinct.
Right, just instinct, hunger, and survival. But the section in these notes on animal emotion and inner lives, it just stopped me. It totally rewrites the narrative. We have to slow down and talk about this.
It's some of the most compelling data in the whole collection.
For instance, cows. Cows have specific best friends. Scientists have measured their heart rates, and when a cow is hanging out with its specific best friend in the herd, its heart rate actually drops. They physically become calmer and less stressed.
They seek out emotional comfort.
And rats, it turns out, make high-pitched giggling sounds when they are tickled or playing. A tiny, joyful chirp. at around 50 kilohertz, which is just way too high for human ears to catch.
It challenges that stubborn human ego that says we are the only creatures capable of experiencing joy or seeking comfort.
Right. And then there is the profound grief of elephants. I read this and just stared at the page. When an elephant dies, its family doesn't just move on. They will return to the bones of their family member.
Sometimes years later.
Years later, they touch the bones incredibly gently with their trunks, lingering on the skull and the tusks, and they just stand there in complete prolonged silence. Sometimes for hours. It's a literal mourning ritual.
It is incredibly moving to witness, and it teaches us a fundamental truth. Joy, community, and grief are not exclusively human traits. We didn't invent them.
They've been around a lot longer than we have.
They are deep, ancient survival mechanisms. Emotions are the evolutionary glue that bond herds and packs together, ensuring they protect one another. Think about the wolves mentioned in the data.
The howling.
Yes, when a wolf pack howls, it's not just to communicate territorial data, they are actively strengthening their emotional bonds. One starts, the others join in, and each wolf deliberately modulates its voice to howl at a unique pitch. They intentionally avoid the notes the others are hitting.
To create a chord.
They do this to create a complex family harmony that carries across the wilderness. That harmony isn't an accident. It's a deliberate expression of unity.
It's a chorus, and realizing that completely destroys the myth of the dumb animal. The hidden geniuses in this material just blew me away. Let's talk about pigeons.
They get such a bad reputation.
They really do. We see them scavenging on park benches and dismiss them, but studies show pigeons can learn abstract numerical rules.
Which is high-level cognition.
If you give them visual groups of objects, they can learn to put them in order from lowest to highest. They can literally do ordinal math.
They possess cognitive processing that we used to think belonged only to primates.
Exactly. And crows are even more intimidating.
Crows are brilliant.
If you are kind to a crow, it remembers your specific human face. If you are mean to it, it remembers that too. But it doesn't stop with that one bird. They will go tell other crows about you.
The gossip network.
Yes. They pass along your reputation in their own vocal language to birds that have never even seen you. Generational knowledge. You could be famous or infamous in the local crow community right now, and you'd have no idea.
You really wouldn't.
And dolphins. Dolphins actually give each other names.
The signature whistles?
Every dolphin develops a unique signature whistle when they are young. And other dolphins will use that specific whistle to call them by name across the water. It's not just a noise, it's a literal conversation between distinct minds.
Which perfectly bridges into perhaps the most fascinating aspect of all this, the human connection.
Let's talk about that.
Because these animals aren't just existing in a vacuum completely separate from us. They're actively observing and adapting to us. You mentioned communication, and there is a brilliant example in the notes regarding cats.
I love this one.
A domestic cat possesses over 20 different vocalizations. But here is the fascinating catch. Adult cats in the wild rarely, if ever, meow at each other.
Wait, really?
Really? That specific varied meowing is a language they developed specifically to communicate with humans. They observed us, realized we respond to vocal cues, and engineered a way to talk to us.
They trained us.
They absolutely did. Furthermore, consider a cat's purr.
The ultimate relaxing sound.
It is, but it's more than that. It sits at a frequency usually between 25 and 50 hertz. That isn't just a sound of contentment. In the medical field of mechanotherapy, that specific frequency of vibration has been shown to dramatically promote bone density.
Not kidding.
No, it stimulates tissue regeneration and reduces pain and swelling. It acts as physical medicine.
That's incredible.
So when a cat curls up on your chest and purrs, it is quietly performing a kind of biological physical therapy on you.
They invented a voice just for us, and they're out here vibrating our bones back to health. It's just incredible.
It really is.
We have covered so much ground today. We started with sperm whales sleeping vertically like massive monoliths in the deep, freezing ocean.
We explored the physics of pistol shrimps creating underwater solar heat from a bubble.
And we journeyed all the way to pigeons doing math on park benches and elephants mourning their dead in the savannah.
It's been quite the tour.
If there is one thing to take away from our time today, it's that the natural world isn't just a green backdrop for human life. It is a wildly complex, deeply emotional, and almost alien world that is happening right alongside ours every single second of the day.
It is a profound reminder of how intertwined we are with these complex systems. The boundaries between us and them are much thinner than we like to think. We're just one highly specialized species sharing a space with billions of other brilliant specialized engineers.
And before we let you go, I want to leave you with one final mind-bending fact from these notes that we haven't touched on yet. The immortal jellyfish.
Ah, the Turritopsis dohrnii.
This is a real tiny creature drifting in the ocean. When this jellyfish reaches maturity, or if it faces environmental stress, starvation, or injury, it doesn't just die.
It hits the reset button.
Through a process called transdifferentiation, it literally reverts all of its adult cells completely back to their earliest juvenile polyp form, and it simply starts its entire life cycle over again. Theoretically, it can do this forever.
This raises an important question. We accept aging and death as the ultimate, inescapable rules of biology.
We do.
It's the one thing we assume binds all life on Earth. But if one tiny, brainless ocean drifter figured out how to biologically rewind its own cellular clock, is aging truly an absolute biological rule? Or is it just a habit that complex life hasn't entirely broken yet? What could humanity eventually learn from a tiny, pulsing creature that never has to say goodbye?
Something for you to mull over the next time you're looking out at the ocean, or even just watching a pigeon on a park bench. Thank you so much for joining us on this deep dive. Stay curious, keep asking questions, and keep exploring this incredible, bizarre world around you. Catch you next time.